Hello dear grade 9 students, and welcome to our chapter, the algebraic expressions related to polynomials, expanding factors and factorization in several ways as well. And here we start with a little revision for the polynomials. As you see here, a polynomial is a chain of monomials. As you see, this is a monomial and this is a monomial and so on. So it's a chain of monomials added or subtracted together. As you notice here, the powers are all natural numbers, so that what specifies a polynomial. You notice it is called p of x because the variable is x and there are real numbers multiplied by each variable. So you have real numbers, you have variables holding exponents, and they are added or subtracted together. Each one of them, each term of them is called a monomial. Now notice I write here that degree of p of x is 7. Let's see what does that mean. And here let's notice this polynomial also, it's q of x. Also it is in terms of x because the variable, as you notice, is x. It's x power 8 plus 0.5 x squared minus 3x cubed, etc. And I write here that degree, this is degree of q of x is 8. So what is a degree? The degree is, as you notice, the highest exponent on the variable. So here the highest exponent among these is 7, and here the highest exponent is 8. Okay, so this is the degree of the polynomial. Now there's something also called the leading coefficient, which is indeed the real number multiplied by the variable holding the degree or the highest exponent. For example, here the degree is on x power 7, it's here, and the number which precedes x power 7 is 1, plus 1. So here the leading coefficient is plus 1. Also here the leading coefficient is 1. It's not always 1, it happened here. So if we have, for example, here 7, then the leading coefficient is 7. If we have it here, for example, minus 4, then the leading coefficient is minus 4. So in short, the leading coefficient is the real number that's multiplied by the variable holding the highest power, which we call the degree. Now how to add polynomials? Here I have p of x and here I have q of x, and I want to add them. So first of all, I have to collect the similar monomials. Here I have 2x cubed and here I have minus 3x cubed. So I have to collect the similar monomials. Here I have minus 3x to the power 5 and here I have x to the power 5. Here I have x to the power 7 and here I have x to the power 7. Also, here I have x to the power 6, here I don't have it. Similarly, here I have x power 8, I have x power 2, and here I don't have it. So these monomials are going to stay alone without being added to any other monomials. Now let's start adding. 2x cubed minus 3x squared is minus 3x cubed, is minus 1x cubed. Minus 3x5 plus x5 is minus 2x5, x to the power 5. 1 into x power 7 minus 5 into x power 7 is minus 4x to the power 7. And as I told you, 0.5x squared, x to the power 8, and minus 7x to the power 6 are kept as they are. Now, if I have to subtract the polynomials p of x and I have minus q of x, so all what I do again is to collect the same monomials as I did here, but I have to pay attention to the signs. For example, I'm going to keep p of x as it is with its terms, and I'm going to change the signs of the terms of q of x because I have p of x minus q of x. So 2x cubed minus 3x cubed, then it will be plus. So I will get 5x cubed. Minus 3x to the power 5 plus, I will put it minus because I'm going to subtract p of x minus q of x. So minus 3x power 5 minus plus x power 5, then it's minus x power 5. The final result is minus 4x to the power 5, as if I'm working with signed numbers, just signed numbers. And I have here x to the power 7 minus x 5x to the power 7, it is a plus, then I will get 6x to the power 7 minus 7x to the power 6 is kept as it is. 0.5x squared is going to be minus 0.5x squared, and x to the power 8 is going to be minus x to the power 8, as you see here. So this is how to add and how to subtract polynomials. Notice something before moving to the next idea, that p of x plus q of x and p of x minus q of x give me a result that's arranged in the increasing order of powers. Notice the powers: 2, then 3, then 5, then 6, then 7, and then 8. So we may arrange polynomials or the result of polynomials in the increasing order of powers, or in the decreasing order of powers. If we start with x power 8, then minus 4x7, then this, and so on. So polynomials are arranged either in the increasing order of powers, as you see here also, or in the decreasing order of powers. Let's continue about polynomials, and here we are going to talk about the root of a polynomial. We have this example: p of x equals x squared minus 3x plus 2. I write that p of 1 equals to 0, equivalent that 1 is a root of p of x. What does that mean? And why 1? That means if I replace x by 1, I'm going to get 0, because I'm going to get 1 squared minus 3 into 1 and plus 2. So I'm replacing each x by 1, because here I have p of x, the variable is x, and here I have p of 1, as if I replace x by 1. So I'm just evaluating to get a 0. Why? Because 1 squared is 1 plus 2, it is 3, and 3 minus 3 is exactly 0. And because I get 0, I say that 1 is a root of p of x. So the root is a real number that when x is replaced by this number, I will get 0 for the polynomial. Here is another example, and I'm saying that p of 2 is 0, then 2 is a root, equivalent to say that 2 is a root. So as if I'm replacing each x by 2, then I will get 3 into 2 cubed minus 2 into 2 squared plus 2 and minus 18. Now 2 cubed is 8, and 8 times 3 is 24. 2 squared is 4, and 4 times 2 is 8. So I have 24 minus 8 plus 2 minus 18. If I collect the positives together, 24 and 2 will give me 26, and minus 8 and minus 18 will give me minus 26, and finally the answer is 0. And thus, because p of 2 is 0, then I can say that 2 is a root of p of x. So finally the remark says a is a root of p of x, equivalent that p of a is 0. So if a is a root of p of x, then p of a is 0. If p of a is 0, then a is a root of p of x. And here is a training exercise to know how to use and when to use this idea. Given p of x equals m into x squared minus m minus 1x plus 4. Notice that besides the variable, there is a real number, a missing real number, that I'm going to find the real number m if minus 1 is a root, given that minus 1 is a root of p of x. Here is the rule: minus 1 is a root of p of x, equivalent that minus p of minus 1 equals to 0. That all what I have to do is to replace x by minus 1. So m of minus 1 squared, here we have multiplication, minus m minus 1 into minus 1. I'm just replacing x by minus 1, and plus 4 equals to 0. Minus 1 squared is 1 times m, it's m. Minus 1 times minus 1 here is plus 1. Then I will get plus 1 into m minus 1, then it is m minus 1 and plus 4. Now m and m is 2m. Plus 4 and minus 1 is plus 3, then 2m plus 3 is 0, and finally m equals 2 minus 3 over 2. That means if I replace m by minus 3 over 2 and I replace x by minus 1 and make calculations, I'm going to get 0 for this polynomial.